be a person that decides to tell me what to do. I don't want that. That's why we started this country in the first place. Like, if we're going to slide towards safety so hard.
That's why you got to deal with people's opinions online that you don't like, because they have the right to express them. That's why I've always been like, people say things all the time, and I'm like, I think that's abhorrent. But they should have the right to post it on, my aunt should have the right to use her Facebook page. Even though I think she should be in jail. I mean,
the problem is also that people don't want people being influenced by people that are full of shit, right? Like preachers or televangelists or some hucksters. They don't want, but I'm not getting influenced by them, and you're not either.
No.
So it doesn't work on people that are paying attention. So we're going to protect people that don't pay attention. And then the hucksters, are we doing that? Or we're not protecting young people. Okay, if we're protecting young people, how young? When I was 21, you couldn't talk with that stuff.
Will, how you doing, dude?
How about you?
I'm doing pretty well. This is great, dude, because like you were late 3 days a week, and now we're starting up online, and you're early. Let's see. What's going on right now? Are you muted? I'm trying to unmute you, and it's. There we go. Say something. Let's see if I can.
Hello.
Oh, okay, cool, good. You're on. Let me ask you something. You have video capabilities, so I could see you or not?
Yeah.
Okay. Well, I mean, you don't have to if you don't want to. I'm just getting set up with this new live action math class stuff. Let me know. Hey, is this in terms of whiteboard setup?
Yeah.
How does that look? Is that good?
Yeah, that's good.
What about this glare right here? I'm seeing a big fat glare. Is that going to make things hard to see? How can I get rid of that? Oh, thanks. Go. A little bit better. Okay. There we go. That works a little bit. Let's see if we can get some more light in here. Oh. Let's see. 8:58. We got about 2 minutes.
What are we going to do today?
We're going to do some review. We're picking up right where we left off when school got out. So, like, it was, let me see if I can remember off the top of my head before I grab this book. We were doing a lot of exponent work and fractional exponents, like x to the third over x squared. What does that mean? And so we're going to review those concepts, like when we have a power, like x squared times x squared, when we have x squared to the third power, and then when we have fractional exponents, how do we deal with that stuff? We'll review those ideas. Pablo is joining us. That's good. Let me make this a little bit closer so it's easier to see. And then after we review that, we're going to do some practice work together on that. And then I'm not sure if I want to do homework or not. You want to do homework? Will, Pablo, you trying to do homework? Okay. I don't know if we'll do homework tonight. We'll start that up when we do the newer stuff next time. So yeah, we're gonna review the three different ideas. We're going to.
Yes, Tony. Now I can mess with them.
Hey, there's Pablo. Let's see. Everyone, this is Chloe the cat. Teaching assistant. All right, that's cool. Get out. All right, if you don't want to be here, you don't want to be here. All right. All right, get out. Get out. We'll probably be in class for like a half hour, not too long. Let's see, it is 9 o'clock, so we're supposed to start now. Let's see. We got, who did I just click it? Yuki? Who's Yuki?
That's me. I forgot I was using this for something else.
Oh,
That's
nice.
So.
Danner, good to see you.
Hello.
I think we're going to get started in like 3 or 4 minutes. 9:05 is a good time. It's just give people extra time to get in. What's everybody doing?
Pretty good.
Not too bad.
Yeah? All right. So I'm playing with this stuff right now. Look at that. I can give myself a clap. Give myself a thumbs up. I've never used Zoom from the host perspective. So I'm still trying to figure out how to make this effective.
And I just woke up.
Good. That's excellent. So this is my office. There's a flag. There's a big comfy chair back there. Normal desk chair. Emma joined us. If you look over that way, bookshelf. I hope you guys are all learning some new stuff. I hope you got time to learn new stuff. Let's see. Participants, how we doing? Cool. Emma, thanks for joining us. Holy smokes, we got 5 kids. This is so funny. I had some parent, that light's making a big shadow on the board, isn't it? That's not good. What if we move it? No. That work a little bit. Cool. Pat, you still in here? No? Good.
What?
I love TV.
Stop it, Tony. Tony, this is my math class, so you should get to your Zoom classes, Tony.
Alright.
Yeah, Tony. What do you even do? What? Yo, so fun fact about me, since we got another minute to kill before people start showing up. My eyes snapped open at 4:15 this morning. Do I know why? No idea. But you just, whoa, Danrick, sick background. That's going to be very distracting. Anyway, yeah, 4:15, eyes snapped open. Don't know why. And so I did a lot of stuff and drank a lot of coffee, and so I'm kind of like, got the jitters a little bit. How we doing on time?
Right about Mr. President.
Cool. Okay. We've got 6 people. Looks like you got Emma, Danrick, Will, Nando, and Adon. Hello, everybody. My name is Mr. Capples. Hopefully you remember me. I'm your math teacher from like a month and a half ago. So good morning to everyone. I think you're all unmuted right now. So if you want to say something or ask a question, get my attention, throw up a hand, and we'll be good to go. What are you guys all seeing right now? Do you see each other's faces on the right side of the screen?
I just see Danrick's.
Okay. Am I in the middle? Looks like Sophie just joined. Sophie, what up? Oh, she hasn't joined yet. She's joining. Sophie, good to see you. Okay. Anyway, do we need to have a chat thing? Do we care about chat? We don't care about chat. Okay. Well, anyway, it is, holy cow, I'm hearing my voice. That's funny.
Yeah, we can hear you.
Well, yeah, but someone's speaker was playing it, and it was a feedback loop. And anyway,
Oh, God.
I'm new to Zoom. We'll figure this out. No problem. So, hope everyone's been doing well. Here's my plan for today. How many of you, I know only a few of you were at the last Thursday, the YouTube Live. And right away, I can tell you that this has been way better and way easier to deal with than YouTube Live already. And I think I mentioned to a lot of you that were there what my hope was for this at-home learning stuff and how we can make some good use of this time. And unfortunately, I was not able to film a separate lesson, or I didn't want to film a specific lesson to start off with new material, since we sort of ended in the middle of a chapter a month ago. So what we're going to do today is revisit a couple ideas that we were studying in chapter 7, and then do a little bit of practice with them. And does anyone here have their textbook in front of them?
I have it somewhere.
Nando, can you open up page, for me, I know our books are a little bit different. Mine's 446, but tell me if you have a chapter 7, like a mid-chapter 7 quiz at page 446. I was at school last week. I probably should have grabbed the student version of the textbook to be more accurate. I'll make a trip over there and find it eventually.
Test. If it says test prep, that means the quiz, right?
What does it say? It should say mid-chapter quiz.
Nope, it does not say, because you said 446. It says standardized test prep.
Can you flip 2 pages, like 2 or 3 pages ahead? Don't worry.
It just shows it shows on how to do exponential functions.
Exponential functions? Oh, we're not there yet. So you're looking at chapter 7.7-5, right?
Yeah.
Okay. So go back a couple pages, or not.
Oh, then it's 439.
439. You see something mid-chapter quiz?
Purple. It says
Mid-chapter quiz still looks different. That's kind of this. Actually, yeah, that's it. Good. Cool. You said 439.
yeah, 439.
439. Easy to remember, kinda. Not entirely. But anyway, so we're going to be taking homework for the mid-chapter quiz. It will not be graded like a quiz, but that's what we're going to be doing. I'm going to say, I'll let you guys, 3, 2, 1, go. Work on that stuff after we review the material leading up to it, which we've all done in class anyway. It should seem familiar. Let's see if I can.
Hey, Tony, if it's the gray cat, that one doesn't get scared. The black cat gets scared.
Okay. So let me rephrase it for another time just to make sure it's very clear. We're going to review chapter 7, sections 1, 2, 3, and 4, reacquaint our brains to these ideas, and then from there, we're going to jumping through the mid-chapter quiz as like a homework assignment. We'll work on some of that in class. I mean, we're supposed to meet for an entire hour. Do we have to meet for a whole hour? I don't know if we do.
No, we do not need to meet for an hour. You sound crazy, Mr. Caps.
I think what we'll do is we'll work on one problem from each of the little sections in that quiz. This says, okay, I think did Caitlin just joined, I think. Yeah, so we'll do like one problem from each of the sections in that quiz. The rest will be considered like homework. And then when we meet again on Thursday, we'll spend that class period going through all of those questions, which ones were hard, which ones weren't hard. That way you get a chance to practice them and then go over the answers because, I mean, we stopped in a very convenient part of the chapter. And then after that, we're getting into some more complex stuff, exponential equations, and it'll all make sense, but not unless we revisit the stuff that we learned a while ago. Let me check the participants. We are up to 8. Let's see, we got Caitlin, Sophie, Emma, Adon, Danrick, Will, and Pablo. Oh, hey, everybody, just so you know, I want to let you guys know, Will was the first person in the class today. He was actually early, which is cool. Completely different than
I think that's a first.
So good for you, Will. I'm proud of you, bud. Keep up the good work.
Thank you.
Okay. So 7-1. And if stuff isn't working in terms of how easily you can see what's on the whiteboard, is it too small, too shiny, whatever, let me know. We're figuring this out together. But the first thing was and negative 0 and negative exponents. Remember, right now we're not.
Wait, am I supposed to be writing this down?
I mean, only if you.
Am I supposed to be writing this down?
Only if you need.
Okay.
This is I mean, you have stuff sort of this in your notes already. We're just sort of revisiting ideas with some different examples so that we can wake our brains back up to math. Because I mean, I wouldn't blame you, but I'm guessing you guys didn't do too much the past 3 or 4 weeks, especially with spring break in there.
Okay.
So the idea with 0 exponents, I'm talking like 4 to the 0. Is that big enough? Or is that mirrored for you? Are you seeing this?
No, we're seeing it right.
You're
We're
seeing it right?
normally. Yeah.
Okay, cool. Mine.
Yes, I am.
Everybody else seeing it correctly? Because when I look at my screen,
Yeah.
like it doesn't look. It looks mirrored. Everyone else is good? Cool. Talking about 4 to the 0th. What the heck does that mean? We're talking x to the 0th. What the heck does that mean? We're talking negative 3 to the 0th. What does that mean? Let's refresh our memories. Anything that the 0th exponent is going to come out to equal 1. If we have x to the 0th, we don't know the value for x, but it's okay. Everything to the 0th power is 1. Uh-oh, we got a negative number here. What happens when we have a negative number to the 0? 1. The only way it wouldn't be 1, and this is sort of rare, is if you have like negative 3 to the 0th. What's the difference between this and that? Well, this one, the entire thing of negative 3 is being to the 0. This one, 3 to the 0th times negative 1. So this would just come out as negative 1. I wrote negative times 1. Okay. This should seem familiar. This should seem pretty basic. And that's why we're going through it sort of quickly. We studied this stuff, and this is just a review session before we get into some more practice with these things. Negative exponents, okay? If we had something like x squared, we know that this is equal to x times x. That's a regular exponent. That's fine. What happens if we have x to the negative 2? What happens if we have 3 to the negative 2. What happens if we have, let's go y to the negative 7. What do we do with this stuff? Oh, hold on. Looks like Zion's joining. Nice.
Potter.
I did not actually expect him to do that.
Well, I mean, I don't expect too many people to show up to anything. I got a class of like 36 kids for second period, and last Friday I had 4. So it's like, whatever. You do what you can. The rule with these negative exponents, let me make sure Zion got in okay. Zion, you good? Welcome to the classroom. Boom. When we have a negative exponent like this, all we're really going to do is flip it over itself like a fraction and make that exponent positive. So it's going to come out as 1 over x to the positive 2. We got something like this, 1 over 3
Bring the capitals.
positive 2. What's up?
What's that? Wait, so what's that again? I lost track for a bit. So was that 2x or oy in there?
Yeah.
On x to the negative 2.
Oh, this thing right here.
Yeah.
That was just a little squiggly arrow saying that, woo, we're going to flip it over.
Oh,
Nothing mathematical about that. I'll get it out of there.
because I was like, wait a minute, I don't remember an OI before quarantine.
Thanks for bringing that up. Anyway, so again, we flip it over. Just do the reciprocal. 1 over 3 to the positive 2. But we can take this a step further because we know what 3 to the second power is. 1 over 3 times 3. 9. Y to the negative 7th. Flip it over. 1 over y to the positive 7th. Is that little 7 too small? I'm trying to figure out what's a good size to be writing for this learning experience. Okay. Negative exponents can be tricky because what happens, I need to get an eraser. I don't even have an eraser. Well, what happens if we have something like 2/3? I don't know, like a 3. 2/3 to the negative. Let me write this. No, we're good. We're good like this. Does this look familiar? Hopefully we've seen this stuff before. We've practiced it. We've mixed it in with bigger things. So let me put up real quick a couple practice problems with this idea that we can then build upon as we go through this review session. All right. I need something to use as an eraser. Here we go. Towel. Everybody good with this stuff? Can I erase?
No.
Yeah.
I heard a no. I'll go for another 30 seconds. And remember, don't feel the need to write all of this stuff down if you're feeling comfortable with it, because it is, it's review. We did this stuff well before we left for our break. Am I going to erase the zeros?
Okay. Okay, I'm done.
Cool. So, quick practice problems. I want you to try these on your own before we go through them. Again, you've done this stuff before, so it shouldn't take too long. Let's get 4 to the negative 3rd equals what? Negative 5 to the 0th power equals what? 3 negative times 3 to the 0th. Let's go 6 to the negative 1. And we'll go -4 to the -2. Okay. So 5 quick problems. Take a second, try those out. Then we're going to go into reviewing another couple other things. Ooh, Daniel Dickens, who's coming in here? Cool. So let's go through. We have a negative exponent. We flip it, and then we have 1 over 4 to the 3rd. 4 times 4 is 16. 16 times 4 gives us 1 over 64 as a final answer. Here, -5, this whole thing is being raised to the 0th power. Anything raised to the 0th power, 1. Up here we have -1 times 3 to the 0th power. So that would be -1 times 3 to the 0th. Well, what's 3 to the 0th? -1. 6 to the -1. Negative exponents get flipped. 1 over 6 to the 1st power, or just 1 over 6. -4 to the -2. Okay. We flip it 1 over -4 to the +2. 1 over 16. Okay. This is the easy review stuff. I'll leave this up for another second. What we're going to get into next is what happens when we have multiple things like this sort of smushed together. How do we deal with it? I'm going to give you one example of that and then one problem for you guys to try, because I don't want to spend too much time in this one section. We got 4 more. Hold on, I got to check something real quick. Had a cat meowing at me. We good?
Yeah.
Wonderful. All right, let's start putting this stuff together. We up the complexity. We learn to handle it. And we're good to go from there. Okay. Here's what I would like to show. Yeah, that's a good one. No, it's not a good one. I like this other one better. 5s squared t to the -1st. Question is, what do we do here? How do we simplify this? How do we make it look better? First, I want us to be really clear what is going on with these in this problem. We've got a number, right? We've got a variable s, we've got a variable t. How are these all connected? They're all multiplied together. The reason we're not really combining them like you would 5 times 7 is because they're different things. While that adds the complexity, it also makes it really easy for us to separate them, simplify them individually, put them back together. We look at 5 just on its own. Can we simplify 5? Nah, 5 is 5. That's don't do anything with it. S squared. That means s times s. Nothing we've really worked on goes to deal with that either. t to the negative first, though, is different. We learned when we have a negative exponent that we need to flip it over like a reciprocal. So this can be simplified as 1 over t. So now we have 3 fully simplified terms. We can multiply them back together. 5s squared times 1 divided by t. That's a nicely simplified expression. That make sense? You good on that? Here's another. I gotta find out a better way to mount this this board. I'm just running out of space, and so much of it is hidden below camera level. Let's take a look at. Let's up complexity some more. We've got 6a to the negative first, c to the negative third. Hopefully the different colors will why it's a different problem. All of this over b to the negative 2, d to the 0th. There's a lot going on here. Is anybody still copying down this first problem? Because I'd like to do the work on this up here. 3, 2, 1, cool. Okay, so I'm going to approach this problem the same way I approached the last one. What do I see? What does it mean? Can I break stuff apart, simplify it, put it back together? And that's what I'm going to do. Let's start in the numerator, the stuff on top. I've got a 6, which is just plain 6. That's the easy part. I've got a to the negative first. 6 over 1. I've got a to the negative first. What do we do with negative exponents? We flip them. So that means we're going to have a 1 up top, a to the first on the bottom. I got c to the negative third. So again, flip it, 1 over c to the now positive third. And then on the denominator, we've got a b to the negative 2. Now what is going on here? Because normally when we have a negative, we flip it, and usually we see stuff go into the denominator. This is already in the denominator. So in the process of flipping that, we're going to end up with b squared on top. And then d to the 0th is, well, that's just 1. So I took each of the terms in this fraction, broke them apart, simplified them all individually, and now I'm going to go through the process of putting them back together. In the numerator, I've got 6 times 1 times 1 times b squared, 6b squared. In the denominator, I've got a, I've got c to the third power times 1 times 1 times 1, a, c to the third. Okay? 7.1 is 0 exponents, it's negative exponents, and it's when you smush it all together, what comes out the other side. Let's do one more example problem. Okay. Anybody still getting this stuff down? Also, I think right now I'm trying to keep everybody unmuted. You can mute yourself if you want, but it's a lot easier for you to say, wait, hold up, I'm copying stuff, don't erase, because, you know.
All right.
You don't have to be unmuted. I'm just saying if you want to get
You, Potter.
But if you guys start goofing around making noise, I'm definitely going to mute everybody, and I'm going to give you all detention. Go to your room.
Oh no. Go to your room.
You should really say it in a fourth
Fine.
period, Mr. Capples.
Hey, what's up?
That's more for fourth period.
My fourth period class had 3 people in it, and so it's like, whatever. I just, kids who want to do stuff are going to do stuff. Kids who don't aren't, and whatever, human nature. I ain't mad at them. Okay, let's do this.
Hold on, I'm getting off the balcony. I'm going to my room. Hold on.
Just mute yourself and move.
All right, last one. Let's go. This unique scenario, we've got 2a to the negative 4th, b to the, let's go 0th power. And the unique thing about this is that a will equal 2 and b will equal negative 4. Okay. Here we have something that's similar to what we've been working on. We got a bunch of stuff multiplied together, but this time we're given values for each of the variables in here. A couple ways we can do this. One way I will do in blue, that is plug these things in and then simplify. So we've got 2 times a to the negative 4th, and then times b to the 0th. I plug stuff in, and then I start to simplify. So 2 to the negative 4th is 1 over 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 2 times 1/16 times 1. We have 2 over 16, 1/8. Okay? We plug these values in, then we simplified, put it all back together, we end up with 1/8. The other way to go about doing it is we simplify first, then we plug the stuff in. So if we look at this, we've got 2 times 1 over a to the positive 4th times 1. Simplifying first, we end up with 2 over a to the 4th. Plug our value in. 2 over 2 to the 4th. 2 over 16. 1/8. Okay. Important thing to note, and this is common in all of algebra pretty much, is that if you do correct steps, you practice the right math methods, you're going to get to the right answer. Okay. If you say, Mr. Capples, what's better, substituting the values first and then simplifying, or simplifying first, then plugging values in, my answer is what makes most sense to you. If you are comfortable simplifying and then plugging in to a smaller expression, do that. If you say, no, I like working with numbers and hopefully those numbers will make things easier, plug in first, then simplify. You know, it's up to you. As long as the math you're doing is correct, you'll be good to go. Let's see. I got to set up a clock at this desk. 9:35. Oh, I don't want to take too much more of your time. So, are we good on this stuff?
Yeah.
Okay. I'm going to go through the next couple sections sort of quickly because I think they're a little less difficult. This next one is multiply powers with the same base. It's chapter 7.2. Multiply with same base. This could be x squared times x to the 5th. This could be 3 squared times 3 to the 8th. And the way this works is by understanding what it is that they're asking you to find. So what we're looking at here is something like, say we've got
your student book, your London boy?
j squared times j to the 3rd. Well, what does j squared on its own mean? What's it a representation of? J times j. J is multiplied by each other. Well, and that's being multiplied by j to the 3rd.
So
J,
you're gonna have to, when
J,
you find it, you need to put it in a place where you will remember
J.
it, because that's not my book.
Okay. Well, what are we looking at now? We've got 2 j's here, 3 j's there, 1, 2, 3, 4, 5. J to the 5th. Exponents are just like consolidation of repeated multiplication. Multiplying the same thing over and over again. Rather than write it like this, you give it an exponent. So how does that apply to x squared times x to the 5th? Well, what shortcut do we see in this one? We got j squared and j to the 3rd, 1, 2, 3, 4, 5. We're just adding them together. So this is just equal to j times to the 2 plus 3rd power. That's all it is. Applying that over here, x squared, x to the 5th. Well, if we use this same little shortcut, it should be x to the 2 plus 5 or x to the 7th. Does that make sense? Well, we've got x times x, and over here we've got 1, 2, 3, 4, 5. Boom, 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 boom. How many x's do we have multiplied by itself? 1, 2, 3, 4, 5, 6, 7. X to the 7th. Okay. So we have this little shortcut. Remember, exponents are just repeated multiplication. And when we're multiplying them together with the same base, we add the exponents. That's the shortcut. You know I'm not big on shortcuts. I want you to understand this is what's actually happening. We have these 2 x's multiplied together, these 5 x's multiplied together, so there's 7 total. The shortcut is we just add them up. Okay. Well, here we have 3 squared, 3 to the 8th. Using the shortcut, that should just be 3 to the 2 plus 8, which is 3 to the 10th. We have 1, 2, 3, 4, 5, 6, 7, 8 3's multiplied. And then we're multiplying in 2 more, 8, 9, 10, 3 to the 10th. Okay. Let me erase this side over here. Now that's kind of it for this section in terms of like how it works. That's everything. What I'm going to show you is just a more complex version of multiplying this stuff together. So let's take 4z to the 5th times 9z to the negative 12th. There's a couple ways to approach it. Check out what I'm going to do. We're going to take the like terms. We're going to deal with them individually, put them all back together. So what number do we see? Plain old numbers. I see 4 times 9. 4 times 9, 36.
Did you knock?
I've got z to the 5th times z to the 12th. Based on our shortcut, I can just do 5 plus negative 12. Well, what is 5 plus negative 12? That should give me negative 7. Now we can write 36z to the negative 7th. Famous question. Are we done? No. Why? What did we talk about last section? Negative exponents. We need to flip them upside down. This is not like that. It's actually 36. times 1 over z to the positive 7. So we have 36 over z to the 7th power. This is just more complex. We have a couple coefficients in there. We have the same base, but when we added our exponents together, it turned into a negative. No big deal. That's what we do. That's what we just practiced like 5 minutes ago. Flip it upside down, make the exponent positive, multiply it back together, and we're good. Okay. Now, if I remember correctly, jumping into 7-4 or 7-3, it should just be raising a power to a power. Should be raising a power to a power. And it is 7-3. Raise a power to a power. What does that mean? It means we get something like this. Y to the 3rd to the 2nd power. Am I cool to erase the right side of the board? Cool.
Yeah.
Waiting on that one person to say yes. This is fun. Okay, y to the 3rd squared. First off, let's review what exponents mean again, just to make sure everyone's super clear. If we got something that says w to the 4th, that means w times w times w times w. We will wear water shoes. Okay? W to the 4th power just means it's w times itself 4 times. That's basic exponent stuff. Here we have y to the 3rd to the 2nd power. What does this 2nd power mean? This means we have y to the 3rd times itself twice. You know what? I'm going to change this. Make it a little more interesting. Let's make this to the 3rd power. Okay, that's what this means. It means we have y to the 3rd times itself 3 times. This looks a lot like what we did in section 7-2, multiplying powers with the same base. In this case, the base is the letter y. So what does this mean? Well, if we use the shortcut we learned, it should be 3 plus 3 plus 3. That's the 7.2 shortcut. What does this actually mean? Well, y times y times y, 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 y is equals y to the 9th. What's actually happening here? What's the shortcut we could see? What we have here is y times, or y to the 3 times 3 power. The shortcut we see here is that when you have a number to an exponent, like 6 to the 3rd, raised to the 4th, okay, well, how many 6s are there? 6 to the 3rd times 6 to the 3rd times 6 to the 3rd times 6 to the 3rd, which is, oh man, I should have picked a different number besides 6. Oh well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We end up with 6 to the 3 times 4. We end up with 6 to the 12th power. Now, normally we'd say, oh, well, we can simplify that. I don't know what 6 to the 12th power is. It's a really big number. I don't have enough room on this little whiteboard. But point being, the shortcut for chapter 7.3, when you raise a power to a power, say you've got x to the a power raised to the b. This is like generic. This is no numbers. This is just basic. You end up with x to the a times b power. That's the shortcut for 7.3. Okay. Holy crap, it's already 9:45. Okay. Let's do a more complex example of this stuff as we've been doing. How about, I'm looking for a good example. Yeah, that one looks good. All right, I'm erasing this stuff. And if it seems like we're going through this stuff more quickly than we normally would, you're correct. We're only doing that because we got limited time. This is a review session anyway. And so I want us to get through stuff and then do a couple practice problems. And then we'll meet up. We'll talk about the other stuff on Thursday. Meet up, talk about the light homework assignment that we got. Heck, I'll just make one up. What if we go with like 3x to the 4th squared. That's a good little one practice problem. And then the next challenge problem will go 3x to the 4th squared times 2x squared to the negative 1st power. So 2 separate problems. Take a minute, try each of them. See what you get. Who was texting me during class? That is not cool. No respect.
Who was it?
Freaking my older sister, jerk.
Oh.
No, she's not a jerk. She's been trying to... Dude, my niece, who's... I think she turns 5 this year, is totally obsessed with Michael Jordan. It's awesome. They watched Space Jam, and now she's like hardcore Michael Jordan, and she's going to be a freaking basketball player, and I'm going to make her go to the WNBA. It's going to be sick.
Oh my god, yeah.
Only if she wants. I'm not going to force it on her. But if she wants coaching and help and getting better, why not? Okay. What do we have right here? We got 3x to the 4th squared. That's the same as 3x to the 4th times 3x to the 4th. What is 3 times 3? 9. X to the 4th times x to the 4th. X to the 8th. Essentially 3 squared, x to the 4th squared. Now over here, well, this looks familiar. It's the exact same thing. We already know that this is 9x to the 8th times all of this. Well, what's going on here? We've got 2x squared to the negative 1st power. The whole thing is to the negative 1st power. So that means this whole thing needs to get flipped over the reciprocal. Okay? If it was just like 2x to the negative 2x, the x squared to the negative, the 2 would stay put. The 2 is in those parentheses. It's included, needs to get flipped. We have something that looks like this. Where do we go from here? Well, we multiply across. We got 9x to the 8th over 2x squared. And I'm actually really glad I came up with this one because this leads into the section 7-4. 7-4 is division of exponent properties, okay? And so I'm gonna actually leave this here, continue simplifying this as an example on this side as we go on to 7-4. 7-4. Division, okay? What happens when we have 9x to the 8th over 2x squared? What happens here? We can definitely simplify this thing. Well, first of all, 9 over 2, we can simplify that. That's what? 9 divided by 2 is 4.5. Or you can leave it as 9 over 2, or, it's fine. What I want to focus on is this x to the 8th over x squared. If we wanted to, fancy word time, if we wanted to extrapolate this, extend this, 9 over 2, yeah. But we know we have 1, 2, 3, 4, 5, 6, 7, 8 x's on top. And we've got 2 x's on the bottom. This should make sense. What does x squared mean? What does x to the 8th mean? This is review, okay? Well, we know that if we have anything divided by itself, it equals 1. So x divided by x, 1 cancels out. X divided by x, 1 cancels out. I don't expect you guys to, when you see something like this, write everything out, start canceling and adding it back. I don't expect that. What can we do? Well, looks like now we have 1, 2, 3, 4, 5, 6 x's on top. If you want to use the 4.5, 4.5 x to the 6th. These are the same thing. They are equal. So what's the shortcut then? We know how it works, so I'll share with you the shortcut. The shortcut is you've got x to the a over x to the b equals x to the x to the a minus b. Now, of course, if there are negative exponents, you can simplify first. Sorry, my knee's getting a little sore. If there's negative exponents, you could simplify those first. If they're and then do this process. If b is greater than a, then x is going to be a negative exponent. So let's see an example of that. Say we've got something like x squared over x to the 5th. Can I erase the blue stuff? I actually want to do this a little bit higher.
Yeah.
Because, you know, with algebra, there's always more than one way to look at stuff. And it's nice to have that variety. Okay, so here's one way to look at it. We got x squared over x to the 5th. If we follow this formula right here, okay, we'll end up with x to the 2 minus 5 power. The numerator minus the denominator, right? That's what we'll end up with. Well, let's see where this goes. 2 minus 5 gives us x to the negative 3, which means we've got to flip this thing. 1 over x to the 3rd. And that way of doing it is perfectly fine. If that makes sense to you, freaking good news, go for it. What's another way to look at this? Well, what's actually happening? We got x times x over 5. So boom, boom. What's left over? Well, we got just a 1 up there. Down here, x to the third. Another way of doing it. It's the exact same answer. I don't really care which way you do. Do which one makes most sense to you. Here's my general way of thinking of it, though, and I think this is going to be the last thing we talk about. Yeah. When I was doing algebra stuff when I was younger and I looked at this, I always thought, well, in this situation, which side of the fraction has more? If we've got y to the third over y to the seventh, which side has more, the top or bottom? Which one has more y's? The bottom. The bottom has more. How much more? 4 more. And that's how I did it. That's how it made sense to me. I mean, I understood this. I sort of figured out how to use the shortcut. That's fine. But I was like, just for the sake of speed, which side has more? This side has more. So that's how I did it. It was fast. You got something, y to the 10th over y to the first. Which side has more? The top. Okay. How much more? 9 more. You can put over 1 if you want, but that's a little redundant. You don't really need it. Okay. And that's the review of the chapter that we did up until quarantine. I'm going to do one problem, upping the complexity, putting all this stuff together. And we're going to end it with that. And I'll assign a small homework thing. But I'm going to pick a nasty one. Let's go with, yeah, that one looks good. 12a to the negative first, b to the sixth, c to the negative third. Remember, we're doing division, so you know it's going to be a fraction. 4, a to the fifth, b to the negative 1, c to the fifth. A lot of stuff going on. This one is a doozy. So for the sake of not getting too intimidated, I'm just going to work piece by piece. 12 divided by 4 simplifies to 3. A to the negative first and a over a to the fifth. Well, we know if we have a negative 1, that's got to get flipped, right? Well, if we put another a on the denominator, 5a and 1 more gives us 1 over a to the sixth. The sixth. We know there's 5 down here. There's negative 1 up here. If we use the shortcut, you know, negative 1 minus 5 gives us negative 6. Negative 6 means it's positive on the denominator. If you want to think about flipping this first to simplify, that's just going to be a to the fifth times a, which makes it a to the sixth. For the b's, b to the sixth, b to the negative 1. It's really similar to what we just did. We use that shortcut, 6 minus negative 1. Well, it gives us b to the seventh. 1 on the bottom. You could also think b to the negative first, we got to flip it. 6 plus 1 is 7. C's, negative 3, positive 5. Just like we saw in both of these, the negative number needs to flip. 5 plus 3 is 8. You could also think negative 3 minus 5, negative 8, right? C to the negative third minus 5, c to the negative 8. 1 over c to the positive 8. Do we see how that works? We've got negatives that need to get flipped. If you do it section 1 style, If we use the shortcut where we subtract, it ends up as a negative, which then gets flipped. So let's put all these things back together. 3 over 1. 3 times 1 times b times 7 times 1 gives us 3b to the 7th. And then a to the 6th times 1 times c to the 8th. A to the 6th, c to the 8th. This looks nasty. We go bit by bit. Numbers, A's, B's, C's, simplify, 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 simplify. Stick it back together. Yeah, it's still kind of complex looking. 3b to the 7th over a to the 6th to the 8th, but it's a lot cleaner and smaller than this giant thing up here. Okay? That'll be our last example for today. Can I explain anything a little further?
No.
So, Nando, you said that the page for the mid-chapter was what, 439? What I'll say is homework. Page 439. Let's go. One to 19, every other odd. What does that mean? That means you do 1, skip 3 and do 5, skip 7, do 9, skip 11, do 13, skip 15, do 17. 1 to 17, every other odd. Now, this will be graded somehow. I'm not 100% sure on the ruling on penalties if kids don't do it. By penalty, I mean like if you don't do it, are you going to get a 0 in the grade book? I got to talk to Napoli and Mr. Walker and see what they all say on that. Because I mean, there's what, 10 people in here at most. There's nine participants, so it's like more than half the class is not getting this right now. So I got to see the ruling on that. But know that on Thursday when we meet, we're going to be going over the answers to this, so we all know what we're doing, and then we're going to start touching on section 7.5. Okay? We good?
Okay.
I saw Danrick's face for a little bit. Saw Pablo's face for a time. I heard Will's voice. I think I heard Zion saying something.
I was here too. That's me, Zion. Hey.
So, yeah, Zion, stoked you're here. But those faces I saw, nice to see your face. Those voices I heard, it's nice to hear your voice. I hope you guys are all doing well. And understand if you need anything, shoot me an email. I know some of you are following the Mr. Capple's Instagram page. I'm usually pretty quick to respond if you got any questions, thoughts, concerns. Mr. Capple's what's on your bookshelf. If you got anything to recommend because you got free time, whatever. CAPPELS. Mr. Capple's on Instagram. Call at me. Yeah. Cool.
Okay.
Have a good day, y'all.
See ya.